And welcome back for the final lecture in your immune system, chapter 22. So we just talked about B and T lymphocytes, and now we're going to talk about why it takes time for the immune system, our B and T lymphocytes, to respond to some pathogen. When our nonspecific defenses start right away, our specific defenses kind of take time and will respond, but it can take, a week or up to 2 weeks before we really see that major response. But what's also happening is we're producing memories. So it's kind of like our immune system has some memories, Anyways, so memory cells are really important because they remember the pathogen, and then if you come in contact with that same pathogen again, your memory cells will respond immediately, typically so fast that you won't even know that you were infected. And we can produce memory not just from getting sick from a pathogen, but from getting a vaccine. You can produce memory cells. So let's look at these graphs. These are showing two different antibodies, immunoglobulin M and immunoglobulin G. So when you get infected with some pathogen, right, at T equals 0, we don't have any antibodies against that, whatever that agent is. And so it's going to take us time. Our immune system will come across it, and then we'll eventually start mounting an attack. But it takes, a couple of weeks before our immunoglobulin G is at a high enough level, producing enough antibodies that we can start killing off the pathogen at a good rate. And then once we've done it, then the immunoglobulin G tapers down. But we still have those memory cells, okay? And this is just what I've talked about. It takes a few days before we get activated, and it takes, a couple weeks before we really see that huge response where we have our immune system is flooded with those antibodies. The second response is super fast, though. So here again, we have the same exact pathogen, but we get infected the second time. That's what I'll say. It takes only hours to maybe a day before our immune system recognizes that there's a pathogen in our system, and it immediately will increase in amounts of antibodies in our system and will produce new memory cells. So every time we get infected, we get new memory. Memory cells can live for years, but you have to produce new memories to have immunity for a lifetime. So we have different types of immunity. There are natural and artificial immune activities. So natural immunity can be active if you come across a disease and you actually get infected and you come down with the cold or the sickness. So right now I'm fighting off an infection, a cold virus. Natural passive immunity is where you're receiving the antibodies directly from mom's milk or through the placenta. Artificial immunity can be active or passive as well. Artificial active immunity is going to be where you are injected with some type of an attenuated pathogen. So something that normally if it was naturally infecting you would cause a disease, but you're getting a smaller dose or an attenuated dose that can't cause the disease, but it still activates your immune system to produce a response. And then artificial passive immunity is where you're getting immune system cells, your antibodies, from another person through an IV. So oftentimes this would be something you might see if you are in the hospital dealing and you have some type of an infection and you can't fight off the infection yourself, or you're getting prepared for surgery and they want to boost your immune system, you would get you would get antibodies via an IV. So the last thing we're going to talk about are vaccinations and some disorders associated with our immune system. So vaccination is a way that we can produce artificial active immunity. We use attenuated microbes. So an attenuated is a weakened or a dead strain of the microbe, but it still elicits an immune system response. So when you get that vaccine, you're able to produce memory cells without actually getting sick. And then anytime you come across that pathogen later on, you'll produce new memory cells. There's a lot of debate, and I heard people talking one day about vaccines, and there are some individuals that can't be vaccinated. Those individuals should not consider themselves anti-vaxxers, because what an anti-vaxxer is someone who doesn't believe that vaccines are beneficial. But individuals that are unable to get vaccines should be pro-vaccine, because what vaccines will do is protect their child even though their child can't have a vaccination. And so there's a video here, this is from SciShow, that I'll put it on for a second to show you it, but I want you to watch this on your own. It's just about the vaccine debate, since we were having some discussion about it. For those of you who don't know him, SciShow, Hank Green is an amazing scientist, and he does a lot of stuff. I don't know why it starts that way. So it's a 9-minute video. It's a 9-minute video, that's why I'm not going to watch it here with you. But watch it. It's a really good video, and it'll give you a lot of information about vaccination and the anti-vax movement. Okay. I'm going to X out of that. There we go. All right. So sometimes our immune system fails to differentiate between self and non-self. And when that happens, then an autoimmune disease can occur. And there are different reasons autoimmune diseases occur, and there are different types of responses. So you could have cross-reactivity where antibodies react to an antigen, but for some reason a self-antigen looks similar to or is able to be bound by that same antibody. Because of that, it kind of mixes up what it's supposed to be attacking and starts attacking materials. If we have blood cell, or if we have cells that don't have self molecules on them, so like our oocytes and our spermatocytes don't have actual self proteins, because when we produce the egg and the sperm, they're only half of us, so they're not going to have just our self on them. And because of this, if our immune system cells can get in contact with them, they will attack. So that doesn't normally happen. We have protective cells that surround our immune system, or our reproductive cells. But if it does, like if that barrier is broken, then our immune system can attack our reproductive cells. Changes in self-proteins. So if we have self-proteins in our cells, and then viruses or other molecules go into our cells and cause the self-antigens to change in structure, that's going to cause our immune system to respond. And then if we have T cells that didn't go through and actually didn't pass both the positive and negative selection test, but they for some reason got by the regulatory cells, then they could actually cause problems as well. And so some of the different disorders, there are acute hypersensitivities. These are autoimmune disorders like asthma and anaphylactic shock, where our immune system responds to things that typically shouldn't. So any hypersensitivity, our immune system is responding to something that it shouldn't be responding to. And acute hypersensitivities are disorders that occur very rapidly. So, you know, if I inhale something, it can cause my airways to close up. If you eat peanuts, that can cause anaphylactic shock. Subacute hypersensitivities occur within hours. The best subacute hypersensitivity example that we have is the blood transfusion reaction, which we've talked about, where your immune system cells attack other blood cells that come into your system because you're getting a blood transfusion. And then it causes the blood to clump up and get clogged in your blood vessels. Delayed hypersensitivities can occur within days of the reaction. And one of the best responses here is diabetes. So where we have we have T cells that for some reason got around our regulatory cells, and in this case the T cells start to attack your beta cells of your pancreas, because the beta cells have been infected with a basic virus like a cold virus. The beta cells for some reason are now being attacked by your cytotoxic T cells, and then those cells get killed off and you no longer have an immune system. The last thing I'll talk about then is acquired diseases, or so these aren't autoimmune diseases, these are immunodeficiency diseases that we acquire. The most common one that we have is HIV, which can cause AIDS. This is a disease that attacks your helper T lymphocytes, and helper T cells are what really cause or control our immune system and our nonspecific defenses. So HIV can be just detrimental to our entire ability to fight off infections. HIV is found by looking for antibodies that attack HIV. At this point, we have, I believe, found some potential cures for HIV. So when this book was written, they didn't have a for sure cure, and we're still looking to see if the cure is something that we can actually distribute. There's also vaccines for HIV that are out on the market. I'm going to be cut off shortly, and so I want you to read through this question, and if you don't know the answer, please bring the questions to class on Tuesday. Thank you, and have a wonderful weekend.